why resistors burn, how they work, and what the stripes mean. Resistors are fundamental components found in almost every electronic device. But why do they sometimes burst into flames? Why are there so many different types? What do those colored stripes mean? And how do they actually work? This guide will explain it all. What is a resistor, and how does it work? A resistor does exactly what its name suggests. It resists the flow of electric current. Think of it like a narrow section in a water pipe. Water can flow easily through a wide pipe, but if you pinch the pipe, you restrict the flow. The water collides with the sides, creating a pressure drop across the restriction and making it harder for water to pass. In an electrical circuit, the wire is the wide pipe, and the resistor is the restriction. Electrons collide with atoms inside the resistive material, making it harder for current to flow. This collision converts electrical energy into heat, which is why resistors get warm. Crucially, a resistor doesn't just slow electrons down momentarily, it restricts how many can flow per second the current, creating a voltage drop across itself. A classic example is protecting an LED. Connecting an LED directly to a 9 volts battery would destroy it, as too much current would surge through its delicate wire. Adding a resistor in series limits this current to a safe level by dissipating the excess energy as heat. Decoding the stripes, reading resistor values. Most common cylindrical resistors use a color band system to indicate their resistance value and tolerance. 4-band resistors common. The first 2 bands are significant digits. The third is a multiplier number of zeros, and the fourth is the tolerance accuracy. Example: brown, black, brown, gold. Band 1 brown equals 1, band 2 black equals 0. Band 3 brown equals 10x. 10 vezes 0 é igual a 100 ohms. Band for gold equals plus or minus 5% tolerance, actual value between 95 to 105 ohms. 5-band resistors. More precise. The first 3 are significant digits. The fourth is the multiplier, and the fifth is the tolerance. Example: orange, orange, black, black, brown. Bands 1 to 3, 3, 0 é igual a 330. Band for black equals 1x 330, vezes 1 é igual a 330 ohms. Band 5 brown equals 1% tolerance. Surface mount SMD resistors use a numerical code. A 3-digit code like I101 means 10, followed by 10, 100 ohms. 4 cassette means 4.7. And R acts as a decimal point, for example. R56 is 0.56 ohms. Why do resistors burn? The power rating? Every resistor has a power rating in watts, which is the maximum amount of electrical power it can safely convert to heat. Power P is calculated as voltage Vx, current I or Ix, resistance R. If the power dissipated and the resistor exceeds its rating, it overheats. The protective coating can catch fire. The internal material degrades, and the resistor fails, sometimes violently. Using a resistor with a sufficient power rating for the circuit is crucial. Larger physical size generally indicates a higher power rating, as it has more surface area to dissipate heat. A universe of types. Why so many different applications demand different resistor properties? Here's a breakdown of common types. Fixed resistors have a single, unchanging value. Carbon film, inexpensive, common. A carbon film is spiraled around a ceramic core. The spiral's length and thinness set the resistance. Metal film, more precise, stable, and lower noise than carbon film. Uses a metal alloy film, wire wound, made by winding resistive wire like nichrome around a core. Used for high-power applications. For example, heaters, dummy loads, where they can handle tens or hundreds of watts. Variable resistors. Resistance can be changed. Potentiometers, manually adjustable via a dial or knob, often used for volume controls or tuning. They have 3 terminals, allowing them to function as a variable voltage divider. Rheostats, specifically designed to control high current by varying resistance, typically using a wire wound element and a sliding contact. Thermistors, resistance changes with temperature. NTC resistance decreases when hot, used for inrush current limiting. PTC resistance increases when hot, used as self-resetting fuses. Light-dependent resistors, LDRs, resistance decreases when exposed to light, used in automatic night lights and light sensors. Varistors, MOVs, act as voltage-dependent switches. At normal voltage, they are insulators. During a voltage spike, they become conductors, shunting excess energy to ground to protect circuits. Specialized fusible resistors, designed to fail safely like a fuse when overloaded, breaking the circuit without flaming. Surface mount device, SMD, tiny resistors soldered directly onto circuit boards for compact, modern electronics. Strain gauges there, resistance changes minutely when deformed. Used to measure force, pressure, or weight. Resistors in action. Basic circuit principles. Current limiting. A resistor in series with an LED protects it. It doesn't matter if it's placed before or after the lead. The same current flows through the entire series loop. Voltage divider, two resistors in series split the source voltage. The voltage at their junction is a fraction of the total, determined by the ratio of the resistances. A potentiometer is an adjustable voltage divider. Current divider. Resistors in parallel provide multiple paths for current. The total current from the source splits between them, inversely proportional to their resistance values. Conclusion! From preventing an LED from burning out to dividing voltages and sensing the environment, resistors are versatile and essential. Understanding their color codes, power limits, and the vast array of types allows you to select the right component for any job, ensuring your circuits function safely and effectively. Remember, the humble resistor is not just a simple component. It's a precisely engineered device for controlling the flow of electrical energy.